I would like to welcome you to this event. I am Andromachi from Cyprus, and I'm the chemical group leader for Mercury in the frame of the European Human Biomonitoring Initiative, and the coordinator of an ongoing harmonized European study in 5 countries, which aims to control prenatal exposure to mercury through dietary interventions. I will begin by presenting an overview of our work, and will throw in some aspects of the implementation of this study in Cyprus, and will then give the floor to our colleagues, the study leaders in the other 4 countries, so that they can share some of their experiences before I come back to present some of our results. Our colleagues from Greece, Professor Sarianis, will then present a biokinetic model for mercury, which was developed and used in the context of our study to translate the biomonitoring results to internal exposures of the fetus and to assess our interventions. Then our colleague from the European Environment Agency will moderate a discussion, which we all hope you will participate in. So I will now share my screen. Are you able to see the slides?
Yes.
Okay, thank you. So our work is being done in the frame of HBM4EU, the European Human Biomonitoring Initiative, which is a European partnership of 30 countries, the European Environment Agency and the European Commission, with the main aim to support policy decisions at EU level for the safer management of chemicals with sound scientific results. Mercury and methylmercury were prioritized for investigation by HBM4EU in 2018. Mercury is among the substances of concern to European citizens. Mercury is ubiquitous in our environment, and in Europe, the primary public health concern is through the consumption of contaminated fish. And because of the potential impacts of mercury exposures on the developing human brain, fetuses and young children are the most vulnerable groups of our population. With regards to the Minamata Convention, there are several articles where human biomonitoring can be of use. When we first initiated our work in the frame of HBM4EU, we started by developing a scoping document on mercury, where we identified the relative policies at European level, the current knowledge gaps which need data for policy support, and suggested actions to be done by HBM4EU. Such actions pertain to creating a frame to assess exposures of citizens in Europe, and to exploit existing studies, as well as developing quality assured new data on the exposure of citizens as well as workers. There were actions, I'm sorry, can you please mute your microphones? There were actions to assess risk and to improve the interpretation of results, such as estimating human biomonitoring guidance values for the general population, as well as reviewing the literature, since the scientific opinion of the European Food Safety Authority came out to try and understand if there are new developments since then. There were activities done to better understand the impacts of mercury on health, and you will hear some of that based on the presentation of the model that will be done later on in this presentation. And we had actions through the study I'm going to present about awareness raising and education of vulnerable populations on self-management activities to control mercury exposure. So when we started to design this new study, we started by a frame of known knowledge based on previous work, One such work was the first European harmonized biomonitoring study, which we performed almost 10 years ago, and which involved biomonitoring of European women of reproductive age. That work demonstrated a large geographic variability of exposures throughout Europe, which was highly associated with fish consumption, and with Southern European countries having the highest exposures. Based on these results, there were estimations of the economic benefit of methyl mercury exposure control in Europe, and this was estimated to amount to the neighborhood of 8 to 9 billion euros annually. However, if one plans to intervene and control exposure of vulnerable populations such as pregnant women, one has to be careful to balance risk communication in a way that will not scare pregnant women away from consuming fish, but to raise their awareness about safer options. So based on that background, we designed the HBM4EU MOM study, whose aim is to control prenatal exposure to mercury through suitable dietary advice. And the study is designed in a way to provide scientific support to several open policy issues. The study is a harmonized randomized controlled trial in 5 countries. The countries were chosen to reflect the countries with higher fish consumption in the south of Europe. Portugal, Spain, Greece, and Cyprus represent that, and Iceland in the Arctic, so that we could capture different fish consumption patterns. Our participants were pregnant women who were recruited through their healthcare providers in early pregnancy, and at which time they provided a hair sample and an assisted interview. And after that, they were randomized into a control and an intervention group. The control group continued with the customary care they received in each country, whereas the intervention group received the advice for fish consumption, which was developed in the frame of the MOM study. Measurements were repeated at a minimum of 3 months after this intervention. So when we designed the study, our preparations focused a lot of attention towards harmonization and quality assurance of our results. With a study like this, where we have samples transferred as well as data transfers across borders, we also had to be extremely careful to create a frame to facilitate that, as well as to obtain our informed consent of participants and to satisfy the requirements of personal data protection and ethics at each country level. And so there was a lot of materials that we created to assist that effort. Our questionnaire was developed in a way to capture fish consumption details from the pregnant women, as well as other associated information. We created communication materials which assisted the recruitment, sampling, as well as the communication of the advice to the participants. And now we are actually working to communicate personal results back to them. And we engaged the train-the-trainer approach to ensure that the teams which were doing the field work were doing so in a quality assured way. Here I show some of the materials we utilized in Cyprus to facilitate recruitment and sampling, and our team was ready to step in and assist at the clinics and even go to participants' homes for samplings if that was necessary. Our model was designed to engage health practitioners, and here I show the case study of Cyprus. The reason we did so is because by engaging health professionals, we were able to proceed with recruitment and samplings over the pandemic of the COVID-19. And we were also building on the trust that a pregnant woman has towards her healthcare provider, as well as setting ourselves up for sustainable use of the results and to better understand the needs of the health sector. Just to briefly mention that our medical doctors, and two of them are shown here, facilitated recruitment and sampling in our country in a very short time. And they were instrumental in the recruitment of participants, communicating the advice, and now they are very much involved in the communication of results. Their motivation to participate was primarily to provide scientifically valid, suitable advice to their patients about fish consumption. But they were also very much interested in the scientific value created, as well as the credibility of the team. The pregnant women who participated stated most of their incentive came from protecting their baby, but also trusting their healthcare provider. With regards to preparing the fish consumption advice, we started by assessing the current situation in each of the 5 countries, and this ranged quite a bit from countries having established advice at national level to countries having no formal advice. But even in the case of having an advice, there is usually no policy to communicate this advice to the healthcare providers and to the pregnant women. In the frame of HPM for EU Mom, we developed the traffic light system to communicate the fish consumption advice to participants, where we denoted fish species which are good choices and should be consumed because of low contamination by mercury with the green color. Whereas we denoted fish species that are bad choices and should be avoided by red. And if the country communicated advice on fish that could be occasionally consumed, that was shown in an orange or yellow color. A lot of effort was done in collaboration of the 5 countries to eliminate any conflicts in the classification of the species across the 3 categories, red, green, and orange. In the case of Cyprus, where we didn't have a formal national advice, we moved quickly to fill this gap, and we developed the advice based on a lot of data on the contamination level of fish species, consumption patterns, and backwards calculations. Here you can see a wallet card which we gave to our participants that shows on the 2 sides the green species which are promoted for consumption in pregnancy and the red species to be avoided. With regards to designing the harmonized intervention, our central theme was that fish is good, eat good fish. And we started by introducing the benefits of a healthy diet in pregnancy, which should include the consumption of fish, but the right choice of which species to consume because of the potential contamination of some species by mercury. We then explained what mercury is and why it is in fish. What health impacts may occur and are associated with mercury exposure. And we finished by presenting the species recommended for consumption in pregnancy and the species to be avoided. We used a lot of different tools to deliver the advice to the pregnant women. The central theme was always that fish is good, eat good fish, but the country was the one deciding based on their national situation on the most appropriate ways to convey this advice. And each study leader in the 5 countries created different ways to engage the participation and maintain the participation of the women. Here I show some of the materials and ways we utilized in Cyprus. We gave an unexpected gift to our participants which was a book, Pediatrics for All. We communicated with the participants by personal communications by phone and text messages. We created a smartphone-friendly web page where we communicated the advice to the intervention group, and we also provided in an open access area a lot of other information relevant to the diet of a pregnant woman and to breastfeeding. And we also collaborated with Greece and with medical doctors at the national level to offer webinars to our participants of general interest to pregnancy. Now I will pass the floor to our colleague from Greece, Catherine Gabriel, who will give some of the insights of implementation in Greece.
Thank you, Mahi. Hello, everyone. This is Katerina from Greece. And first of all, I would like to thank the organizers for this great opportunity to be part of these side events and present the work done in the frame of HBM4EU and the human BioMonitoring on Mercury in the vulnerable population of the pregnant women. As Mahi presented earlier, Greece is one of the 5 countries participating in this harmonized study. And we would like to stress that Greece was originally designed to be, the study in Greece was originally designed to be regional and cover the pregnant population on the city of Thessaloniki. That's why we first went to the obstetricians and gynecologists, and we managed to engage 2 clinics and 5 medical co-doctors in the city of Thessaloniki. But the challenges that we face, especially due to pandemic COVID-19 and the repeatable restrictions, such as lockdowns for long periods and inability to visit medical units, hospitals and clinics, was the reason to adapt our model. And that's why we engaged to our study a private midwife and promote the study through the social media. Working on this way, we went up to have a national study with participation of women from more than 20 cities in the whole Greece, as you can see in the map, including participants from the capital of Athens and the nearby cities, participants from 5 different islands, including Creta and Rhodos, and of course the city of Thessaloniki and all the nearby cities covering the 60% of the participants. That was easy to be done because the matrix that we use for the human BioMonitoring in Mercury is hair, and it's easy to travel across the area of the whole Greece. As it was said before, HBM4EU study was an intervention study, and half of the population, and that means that 2 different samples were sampled from the same participant at 2 different time points. Half of the pregnant women as the control group follow the same dietary habits as before, and the rest are instructed to follow a nutritional recommendation concerning the consumption of fish for more than 14 weeks. This presupposes that the interest should be kept undiminished in both of these groups until the second sample. And that's why we choose to offer completely free webinars during this time to all participants on subject that has to do with the breastfeeding, the choices that they have to have the birth of their baby, then parenthood based on the principles of the attachment parenting, and especially to the women that they follow the intervention, we offer 2 extra webinars on balanced nutrition and during the pregnancy and during the lactation period, and to stress the need to consume the right fish in the right amount during these periods of their lives. Moreover, we provide to the intervention group a pregnancy calendar where women were asked to record their fish consumption in a weekly base. So we end up in the second phase of the study with 126 samples versus 130 samples that we have from the phase A, and that's because of medical and personal reasons of the participants. With the second sample collection, we give a thankful gift back with the log of the study and products from 4 different pharmaceutical companies and for the babies and the pregnant women, and the certificate of participation. With the completion of the second phase, it was when it was completed, also the national database for both phase A and B was completed. And with collaboration with the institutes of JSI, ISKI, VITO, and AUTH, we are now working on the statistical analysis in order to understand the findings of this study. Now we're in the point where we are contacting the participants and communicating their personal results through their medical doctors and or directly by emails. The last thing that we want to share with you is that we have prepared a poster that we are going to provide to the clinics, to the medical doctors, to the midwives, the pharmaceutical companies, presenting the study and the advice of the study in order to cover their gap of the nutrition guides that exist in our national system, and it is the interest of the pregnant women to follow a proper fish consumption during pregnancy and lactation. That's all for Greece, and
thank you, Catherine. And now I would like to give the floor to the study leader from Iceland, Dr. Þórhallur Henderson. Thor, the floor is yours. Thank you.
Thank you. Can you hear me?
Yes.
So basically, in Iceland, we recruited women through a 5-month period, starting in the summer last year. And the recommendation in Iceland is such that there are official brochures that each pregnant woman get, where there are recommendations on fish intake, where pregnant women are advised to eat about 2 to 3 fish meals per week, preferably one of those fatty fish. The fish consumption is generally quite high in Iceland, but there are also recommendations to limit the number, limit consumption on certain predator species such as large halibut and, of course, whale meat during the summertime, which is available in certain seagull eggs and so on. And we recruited women through 9 healthcare clinics using 15 midwives in the Reykjavik capital area, and the number of births there is about 2/3 of all births occurring in the country. And I think we sort of, during the recruitment period, we managed to, the number of women that we recruited, which was about 120, constitutes about 6% of all births in the country. I mean, the number of births is not that large in this country. And the phase A during the summer recruitment went quite smoothly. There were not a lot of problems, and we were relatively happy. But COVID spiked again in the autumn, meaning that the pregnant women tended to isolate themselves. To some degree, there was a huge burden on the healthcare system and the midwives that we needed to remind them and be constantly in touch with them in order to keep them motivated to finish the process, and that went very well, but we had to adapt relatively quickly. And for those women that we missed through the midwife healthcare clinics, we had to contact them ourselves and collect the samples. And in some rare cases, the women didn't want any contact at all especially when the COVID incident was high. Next slide, please. And we managed to recruit 120 participants, and in the phase B, we managed to get 106 of those. Again, very few women didn't want to continue the study, but I think there were 4 or 5, but the rest is basically lost to follow-up. And the main challenges were COVID. I think we would have had, it would have been much easier if COVID hadn't been around during the recruitment process. The other obstacle, we suddenly realized that Iceland is not a formal member of the EU. And that meaning then when you send packages with samples, that's quite labor intensive to get them through customs, especially when you don't speak the language. And I can also say that, we are working 5 countries together. The type of fish species that we consume is different, and harmonizing the whole thing could be a little bit labor intensive at times. But the main lesson is that, everything went well, given the fact that we were doing this during a pandemic, but it's important to keep sort of processes as simple as possible. And I think we managed to do that to a large degree. Thank you.
Thank you, Thor. And now we go to Spain, and the study leader there was Marta Esteban Lopez. Marta, the floor is yours.
Thank you, Andromaki, and to the organizers, to the opportunity to show our work, and good afternoon, everyone. HBM4EU MOM in Spain has been coordinated by the National Center for Environmental Health of the Instituto de Salud Carlos III, and this center also analyzed all the hair samples in this study. And also the ISTE team, the ISTE team is formed by several researchers and technicians. And here you can see on the right, you can see the sampling location. That was the University Hospital of Fuenlabrada, located in the city of Fuenlabrada, Madrid, with a population around 193,000. This is a public hospital that serves a population of more than 213,000. We had fieldwork team in the hospital. No,
I'm sorry.
Can you come back?
Yes,
Thank you.
yes.
We had a fieldwork team in the hospital with several doctors, nurses, and midwives that were trained by us on how to collect the hair samples and conduct the study. They recruited all the women, but although the majority of the samples were collected in the hospital, due to several reasons, we also need to visit some of the participants at home for collecting the samples. And we also here in the ICSI performed the questionnaire by telephone. Next slide, please. Thank you. Well, the COVID pandemic made things difficult, but fortunately we were able to follow the initial study design, and so we made the first sampling within the first trimester of pregnancy, and the second one after birth, and we complete the harmonized study with additional samples of dried blood spot sample from the mothers and the babies. We adapted the harmonized material of the study to the national needs, and in order to minimize the impact of the fieldwork on the hospital activities, we prepared individual kits, including all the material for sampling, the information leaflets, the informed consent, etc. Regarding the intervention, the control group did not receive any information by us, only the recommendation provided by the doctors about general healthy diet during pregnancy, and the intervention group received the national recommendation on mercury and fish consumptions. These recommendations were defined in... please, can you go to the next slide? Sorry?
Yes.
Yeah. These recommendations were defined in 2011, and they were updated recently in 2018. And they are available on the website of the Spanish Agency of Food and Food Safety and Nutrition. Participants in the intervention group received a leaflet that you can see on the right with this recommendation. And we also prepared a wallet card showing the species to avoid on one side and the recommended species on the other. Next slide, please, Andromaki. Thank you. During the intervention, we had a very fluid communication with the participants via WhatsApp. They reported their fish consumption by sending to us pictures of the meals that they prepare, and we send reminders and information to the women, and also links to healthy recipes elaborated with the recommended species. And well, they even sent to us some picture of the meal. It was really nice. Next slide, please. To finish, I would like to share with you some of our first thoughts and reflections about the HBM4EU MOM study in Spain. It's true that fish consumption recommendations are available online, and several communication campaigns has been implemented in Spain, but we still need to continue working to include them as a common recommendation for pregnant women in the primary care centers and the hospitals. And in the same way as they receive recommendation about other foods and during pregnancy. Well, currently the knowledge in the clinical setting about the exposure to mercury by fish consumption and the potential risks for fetus and children is better than some years ago, but however, there is still a lack of let's say, interest or experience of the doctors in human biomonitoring and its applicability in this field. We have learned that the individual content using a smartphone is a very useful tool in this kind of study. It's really works. And as I said, it was necessary to visit some of the participants. This is because they decided to give birth in a different hospital. And sometimes they allowed to do the sampling at their homes, but others were a bit reluctant. And in these cases, it was crucial to have the mobile laboratory, what is key support in human biomonitoring studies. And finally, my last reflection is for the difficulties derived from COVID-19 pandemic. It has affected to all of us, but please be aware about the huge difficulties that the hospital's team have to overcome during the implementation of this study in parallel with their responsibility. They had to work under hard conditions because of the COVID restriction, and even so they achieved the goal. So thank you so much for that. And that's all from Spain.
Maki, you are muted.
Yes, I'm sorry. I was introducing the study leader from Portugal, Sonia Namorado. Please go ahead, Sonia.
Thank you, Andromaki. And also thank you very much to the organizers for the invitation to present our study, and to all the presents who are giving us their time. So at the beginning of the study in Portugal, we had no national official advice available, but however, recommendations from the Portuguese National Program for the promotion of healthy eating were developed for pregnant women and made available in their website. So if you go to the next slide, we will be able to see, next slide, please.
Yes, here.
Okay, we will be able to see that these recommendations are in line with what we were foreseeing for our study. So they recommend the consumption of 2 to 3 portions of fish per week, and they produced lists of fish and seafood species to be avoided, to be eaten only once a month, and for free consumption. So we have used these recommendations in the Portuguese MAM component of the study. So in the next slide, you will see that concerning the recruitment, we had initially foreseen to do it through the primary care teams in the Lisbon area, but the pandemic has overloaded the health services, and a few health units have agreed to collaborate in the project. And those who have agreed have only agreed in disseminating the project to the pregnant women. So they were not available to collect samples or to make contacts or questionnaires. So we have to come up with new solutions. And these solutions were to make the sample collection and the questionnaire by the project team, to disseminate the project through the institutional website and the social media. And on top, you can see an image that was published in Facebook to disseminate the study. And also, we have decided to expand the study area to include other locations of the country outside of Lisbon. This has allowed us to increase our recruitment rate, but it was not enough for the goals we had. So we had to make some additional efforts. We have produced a press release for the media, and we were able to have several newspapers in Portugal publishing the news saying that we were developing the study and we were looking for participants. Also, we had a radio channel who interviewed us, and also that was very good. And you can see on the image below the news in the radio channel website. Also, we have been able to ensure the collaboration of a private hospital in the Lisbon area. It was a difficult process and time-consuming. We have to have a lot of authorizations. And we were allowed to go there to perform on-site recruitment at the hospital, but it had to be our team to do it. Even so, if you go to the next slide, we were able to finish phase 1 with 135 participants. You'll see here that most of them were from the Lisbon area, but we had participants from other regions in the country. Then for the intervention period, we had developed a newsletter that we had sent our participants by email on a regular basis, as you can see here. And in phase 2, we were able to secure the participation of 113 participants. We had 3 dropouts due to miscarriages, and the remaining dropouts were due to lack of trust and fear caused by the increase in the number of COVID cases that we had starting from before Christmas and until the beginning of this year, which was the period in which we were doing the field work for this phase. So just to conclude, in my next slide, I would like to share some reflections and lessons learned. So in Portugal, field work presented extreme difficulties because the healthcare teams were very involved in the pandemic and they were not able to support us. So the study team had to come up with new solutions and fortunately was able to overcome these obstacles. Crucial to this were the recognition and trust of the public at the National Health Institute, the entity who is doing the study at the national level. The COVID actually helped a lot with this because we were making a lot of studies for COVID. So the name of the institute was very well known by the public. And also the possibility to collect the samples at home at our institutions was also very important to secure the collaboration. In doing this project, we became aware that most women are worried about the possible health effects due to mercury exposure, but they are unaware of the proper procedures to avoid exposure. So we think that recommendations should be given regularly at the primary care services, and national communication campaigns should be devised and implemented, as done in Spain when they have updated their recommendations in 2019. Thank you very much.
Thank you, Sonia. So now I would like to present some preliminary results from the MOM study. These are some results from the questionnaires that the women completed through interviews. One of the things we learned is that the timing at which women who make dietary changes for the pregnancy is usually when they learn they are pregnant. So with regards to prevention of prenatal exposures to mercury, it would even be important to raise awareness of women as they prepare for pregnancy if it's a planned pregnancy. I'm trying to transition. About 43% of our participants said they didn't make changes in their diet for the pregnancy, and the major reason was because they believed their diet was already balanced. However, most participants said that they are willing to change their diet during their pregnancy if they knew it would benefit their baby. In terms of receiving new dietary advice for pregnancy, if that became available, their primary choice is to get it through their healthcare provider. With regards to their attitudes towards fish, most participants believe that fish is nutritious and it's safe to eat during pregnancy, but I would like to point out that there is quite a range of percentages based on the country. So for example, Portugal had the highest percentages of women thinking that fish was nutritious and safe. And now some of our results from the exposure to mercury based on hair measurements. On the graph to the left, you can see the exposure levels of all 654 participants in phase 1, that is the exposure in early pregnancy in the first trimester per country. You can see that all the countries had a geometric mean below the current guidance values, cutoff values suggested by the European Health Safety Authority, which is in orange, as well as the level of the World Health Organization. And you can also see the results of the exposure at country level during phase 2. This is the whole population, both the control and the intervention group. You can see that our most highly exposed country, Portugal, has a very pronounced, there is a drop in the exposure. But you can also see that on the right-hand side, we show the percentages of women exceeding safety levels. There is a drop in the amount of participants that have exceedances of the cutoff levels. And we are now working to better understand the data and to also make association of the exposures with the fish consumption patterns that the women provided through the questionnaire information. I would like to finish by summarizing that our work in the frame of HBM4EU has a lot of relevance to the Minamata Convention, to several articles of the convention. So, for example, with regards to the effectiveness evaluation, results from the MOM study can be of use. What the materials and the frame we developed for communicating advice for fish consumption in pregnancy is useful with regards to providing information to the public. We have a lot of work which was done and is accessible to interested parties on the HBM4EU website. And all the publications that are coming from our work are open access publications. I would like to finish by stressing that our work highlights the importance and the success of cross-border mobilization of resources and expertise to tackle global risks such as those imposed by Mercury. And we are looking forward to continuing our work in the frame of the upcoming new European Partnership Park for the risk assessment from chemicals. I would like to recognize our colleagues throughout Europe. Although the MOM study took place in 5 countries, we actually had colleagues from 10 countries who supported us in this work. And of course, I would like to thank the 654 pregnant women from Iceland, Portugal, Spain, Greece, and Cyprus that made this project possible. And I thank you for your attention. I would now ask Dennis Arianis to present the results from the modeling.
Thank you, Andromachi. Let me just share. Oops. Yes. Okay. So thanks a lot to everyone for being here at this time. What we've done in addition to biomonitoring in terms of the recruitment, sampling, analysis, and as you saw already preliminary statistics, is to actually use the biomonitoring data to feed into biokinetic modeling of methylmercury and mercury in the context of the study and try to estimate intake levels, also potential exposure to the fetus, because we're talking about pregnant mothers, and indeed levels of dose, biologically effective dose in the brain of the fetus. So this is, we use the Integra platform that was developed and before, but also adapted and optimized in the course of the HBM4EU project, which is providing an operational link between integrative exposure modeling and human biomonitoring, connecting different type of sources to external exposure pathways and routes, and also then to internal exposure distribution, but also sort of armed with exposure reconstruction algorithms that allow us to connect HBM data and convert them into intake values, which I think is very relevant for toxicological risk assessment. Indeed, this is the missing link, how to convert exposure to internal exposure and actually then eventually link this to all different types of toxicological assessments. And this is how we developed this is why we developed this model for mercury and methylmercury in the context of the study.
Dennis, may I interrupt you? I see some comments coming that your sound is a little bit distorted.
Yeah, well, I need to move on because we don't have enough time, Mahi. So what we have done is to account for a number of toxicokinetic properties, including, of course, absorption, differences in absorption between methyl and elemental mercury, distribution, conversion in terms of oxidation level, of course, accumulation properties, especially with regard to the central nervous system, and in this case, the cerebral cortex. Actually, the fact that methyl mercury in fetal blood is approximately twice the content of the maternal blood, and also the differences in terms of excretion, where isotopic mercury is essentially excreted by the feces and only to some extent in urine, whereas methyl mercury mainly in feces. Therefore, methyl mercury is not biomonitored in urine, and of course the differences in biological half-lives. All this is gone into this coupled model of methyl mercury and mercury, PBPK model, which actually takes into account the interaction between the mother and the fetus. And through that, we could actually then estimate the equivalence of the biomonitoring data with the actual intake using this exposure reconstruction algorithm, which runs as you see right now. So we are essentially running using a Markov chain Monte Carlo approach to many thousands of times the PBPK model to reconstitute the monitoring value profile, and then eventually correct for differences through an optimization algorithm that allows us then to estimate the final, let's say, most plausible intake distribution. Based on these calculations, we could actually convert the biomonitoring values that you saw before into methyl mercury intake. And here you see the comparison between phase 1 and phase 2 across different countries. In terms of intake, actually, you have Portugal and primarily where the median values actually exceed the EFSA TWI, the tolerable weekly intake value, and the median value in Spain is close, but clearly not exceeding it. In terms of the actual difference in intake between the different countries, you see the vulnerability based on also on the biomonitoring data, and of course we have incorporated all the different types of uncertainty factors that come into play. That's why you see very large distribution bar, error bar charts. But this is a very reliable calculation based on that. And sorry, because oops, that moves fast. And with the PBPK model, we can actually estimate the kinetics of the effect of the intervention, so the effect of reducing, essentially in this case, mercury-loaded fish consumption after the third month throughout the pregnancy. So you see what you would expect to find based on the PBPK models in the different types of biosamples that one could actually obtain. So you can actually see the relationship dynamically between, for instance, blood levels of mercury and hair. On that basis, then we could actually go back and estimate how much of this mercury could actually reach in this case, in the form of methyl mercury, the brain of the fetus. These are the different the variance of the values. Of course, again, Portugal and Spain are higher than others, but you see also that there's also a more significant effect in terms of reduction in these countries, which you will see here. So I think the take-home message is that this kind of approach allows us to translate HBM data into intake levels, which is more relevant for risk assessment. So if we take the intake levels, then in Portugal, there seems to be an exceedance, which hopefully with intervention like this actually could go really down. We have estimated that the reduction in Portugal, for instance, was in the order of 15%, about 19% in Spain, and so you see these countries with the higher levels of intake actually showed the highest change during the interventions. for the reason we discussed previously by the different colleagues in the countries. And what I think is very important is that the reduction of maternal intake levels is reflected indeed in the reduction of internal exposure to the fetus, which I think is what we are really aiming at with this kind of public health intervention. The next step for us is to investigate the contribution that the different dietary sources and seafood components would actually have on the overall intake, just to be able to actually enrich the overall advice and indeed the public health intervention associated with dietary mercury exposure of pregnant women. Thank you.
Thank you, Dennis. So, Rosaire, would you like to take the floor and encourage the discussion with our participants?
Sure. It's been quite intense, the debate. So there's been some sort of debate in the chat. But I will just summarize like the first main question, which the question was on whether it's possible to conclude the rate of mercury if it's lower in freshwater species versus seawater species. So there was a participant saying it depends the level of mercury on the size of the fish, whether this is predatory or not. But then someone else was also explaining that perhaps freshwater fish that are close or near to mercury sources, for instance, from mining activities, might contain higher levels of mercury than others coming from the sea, that the water is less contaminated. So can please any of the speakers could just reply or just complete that debate, please?
Yes, maybe I can start by saying thank you, of course, for the question. It's very, very important. I should mention that in the countries where there was a national advice in place, there was an existing advice. We started with that advice. In the case of Cyprus, where we developed the advice, I can give you some of the scientific background that went into the thinking process to classify the fish. Of course, we looked at a lot of data on the occurrence of mercury in fish by different species. And we also considered frequencies of consuming different types of fish in the country. So a lot of that is taken into consideration. But the other novelty of the MOM study is that we created very detailed questionnaires. And so we collected a lot of detailed information from the participants with regards to the species they consume, if they knew the origin of the species, any changes in seasonality, portions, and so forth, and whether the fish consumed is freshwater or marine fish. So we have a lot of information, and we're just now starting to look at it. So I don't know if I've answered your question or any of my colleagues would like to add anything else.
I think that if I can add something.
Please, Argelia Castaño from Spain.
Yeah, I'm director of the Center of Environmental Health in Instituto de Salud Carlos III, Spain.
And she's also a pillar leader in the frame of HPM4EU.
Thank you, Andromakis. No, actually, the main problem of mercury in species are much more related with seafood and the predatory movement of the species. It's true that originally there was some lake water that were particularly contaminated with mercury, but it's not the case anymore. Has been very much treated. So the biggest risk in mercury contained at the moment is much more related with seafood and the size of the fish. Regarding the comments that were in the chat, as far as I was just reading, as you very well pick it up, Rosaire.
There's another question.
There are some areas in South America with a very intense artisanal gold mining that is a lot of fish contaminated there, but it's not the case anymore in the rest of the countries.
Moving on to a second question posed by Karishma. She said, how is the consumer supposed to know which fish contains little or not mercury? This is a challenge for consumers. So anyone who would like to answer, please, the floor is yours.
But I think the advice was made in the MAM study were very much taking care exactly on this. As a general rule, just for the consumers to know, big species has larger mercury contamination than smaller species. Just as a very simple rule for normal citizens, are that these big species have more amount of mercury than small species. This is a very simple advice for the consumer.
That is a very simple advice, but I agree with Angelia. But we also have from other studies run in the Mediterranean and actually in the east, from Spain all the way down to Greece. There's also a very significant dependence on geolocation, on the origin of the local species. For instance, even we have found actually a number of Greek sardines having much higher mercury content than larger species. That was an unexpected finding, not from this study, but from previous ones. But which actually was primarily of geological origin. The mercury did not come from contamination or from anthropogenic sources. It was actually naturally occurring in the sediment of in this particular part of the sea. So it does depend. But I think, as mentioned by Mahi and Angelia, in the MAM study, we did classify the fishes and actually based on the potential for mercury exposure. And this is a valuable, the integrated conclusions which will be coming out of the study will be a valuable input in terms of being able to enrich the advice, also with regard to the kind of fish that will be more relevant.
So I would like to add that one of the benefits of the MAM study is that we combined the provision of the advice with human biomonitoring assessment. So one of our tasks is now to understand how the fish consumption patterns that the participants declared, how they relate to the levels of mercury in their hair. So that will be very important and interesting to see from our results. Thor, I thought you wanted to continue.
Yeah, I was saying, I mean, all these advice about, freshwater versus sea and close to local contamination, I mean, all the advice in each country has to be based on local expert knowledge because, I mean, we monitor the levels and we can correlate. And this helps. This is a biomonitoring component on top of an intervention study. And this really helps us individually in each country to develop or refine the dietary advice that we give, but also a cross-country understanding of the main drivers of mercury exposures, because a lot of these species are sold generally on the European market. So, I mean, with all the advice, I think would have to be local to some extent, as has been pointed out.
And there are a couple of minutes more before we say bye. Mr. Thomas Cohen from the audience, he asked, to which compartment the biological half-life belong? So perhaps he can take the floor and just elaborate a little bit more the question. Or if not, in that minute left, I think I'd like to give the floor to Dr. Argelia Castaño, and perhaps like in a nutshell, in less than a minute, if as a takeaway message, you could explain the role of HBM for you as public health tool.
Yeah, thank you very much, Roser. I just like to point out in few words the important role of human biomonitoring to really the implementation of the many treaties, in this case, the Minamata Convention treaty. And There is a in one of the slides that Andromachi shows how the levels in many countries that we participate in Demographics 2012, the average level of mercury that was checked for human biomonitoring was decreased after these 5 years. And we can check this thanks to HBM4EU project. Means that human biomonitoring is a public health tool that is the way to really check how implementation of the different advisory or measures, environmental and public health measures, can be checked and can be tested. And this is the most relevant, useful tool for check this in the service of public health authorities and policymakers, of course.
Thank you, Argelia. And Dr. Andromachi, would you like to close the session, because we need to close now?
I would like to thank all our attendees for joining us this afternoon, and thank you very much for your questions and comments. I would like to also thank all of our colleagues, both the ones that presented and the ones that were not able to take the floor here. And if you have any questions or need to get in touch with us, we'll be happy to take any questions on a bilateral basis as well. But do visit the project website. There are a lot of resources there that could be of use to you and your own work. Thank you. So Roser from the European Environment Agency, thank you for moderating the session. I think we can close the meeting now. Goodbye, everybody.
Bye, everybody.
Goodbye, everyone. Thank you.
Bye. Thank you.
Bye-bye.
Bye.